Okay, excuse me guys, can I have your attention please? So we are supposed to start our next session at 4:30, but it seems that we have some issues trying to get the slides on to the screen. So if you guys can just bear with us for a moment. You okay? Yeah. All right.
Izquierdo.
Test.
I'm sorry for the waiting. I'd like to introduce our presenter today. He's izquierdo. He's Venezuelan and he's a developer at the Make Leaps. He just came to the Tokyo last year and he is doing a lot of Django development and also interested in Python in general.
Okay. Hello, this is my talk about SaltStack. I'm working currently at a startup based in Tokyo, and we've adopted since this year Salt as a way to manage our infrastructure. So I'll be talking a bit first about what SaltStack is. Then I will go over its remote execution capabilities, its configuration management, and then talk a bit about how our process was to go from an ad hoc kind of setup to using SaltStack to manage all of our infrastructure. Our use case, and maybe like a very typical use case that a lot of people find is, so I want to develop a web application, right? So I begin by installing a web server and a DB server in my laptop, and then get everything set up and configured to develop. Then I start developing for a while, and then finally I get a good enough product to put it on a remote server and start actually maybe getting users. And then I need to spend like 1 hour configuring everything to get the same setup that I had on my laptop to work and serve requests for the users. Then maybe later some other developer joins me, so that developer also needs to put, configure everything in their workstation to get everything set up. And then maybe I'll switch data centers because my current one isn't good enough. Maybe, yeah, it turns out I put everything there and I can't get my app to work there. And yeah, I remember that I had to install like obscure package 142 because the next version was incompatible with my application. So I started getting like all these little details about how I need to set up my environment for my app to work. Then maybe I'll buy a new laptop, so set up everything again in my new laptop. And then spin up a staging server because now I'm at the point where I want to test everything before putting it into production. So that's another server to configure. And then I have to remember to put everyone's SSH keys in there so that the developer can log in and do actions on the server. And then I need to remember to install each new package that I install in my laptop, in the production server and in the staging server, and also like on every one of my coworkers' environment. And then, yeah, the PDF is kind of my notes are in there, but. And then finally, I'll cry when a customer asks me to like set up a custom demo server for them, because yeah, I just need to go through a whole process that I'm kind of tired of doing, and it's error prone. So to solve this problem, I'm introducing Salt. Salt is a platform for infrastructure management and automation. So basically, the main things it supports are remote execution, configuration management, but it's also an extensible platform, so it supports a lot more features, and it's extensible to solve many kinds of different infrastructure management problems. So I'll talk first about the remote execution capabilities of Salt. Salt provides, in its essence, a set of functions and a system to run those functions in a remote server, right? So, for example, let's say I want to list all the files in my app server, which is app01.example.com. So I want to get a list of all files in that directory. So, for example, Salt provides me the capability to do this easily from a central server. I could run the Salt command and specify that I want to run a function on this machine, and then specify command.run. So CMD is a module of Salt in this case, and run is a function of this module. And what this function does is run an argument in this remote machine, and then I pass arguments which are ls/temp. So I'm going to run this command in the remote server, and yeah, I'll get a result like that. So basically, app01 replies with a list of all the files in this directory. Sorry. Okay. Now, what happens if I want to run this command in many servers at once? I can also do that with Salt. I type again my Salt command, but now I specify a globbing pattern to say in which servers I want to run this function, and the same command.run function, and the same command that I want to run, and then I get a result of running this function centrally in the machine that I'm working on. So yeah, this command ran and gave, I got all the output from all of the servers. And then there are more applications. For example, I could say, I want to check that all my servers are up. So I again run the Salt command, but I use a globbing pattern to match all the available servers, and run the test.ping command this is not the same as the networking ICMP ping. This is a function that's defined by salt, and it runs and basically gives me this result, right? So I here get a reply from all of my available machines, and I get true, which is the result of running this function on all of these machines. So I know these 4 machines are up. So this is for one example implementation of this function, right? So if I define a ping function that just returns true, this is what's actually running in all of the servers when I run this previous command. So yeah, going back to this, what Salt did here was order this previous function to be run in all of the servers and gave me back the result, which is true. Obviously, the servers that are down are not going to reply back. Here's another example, a bit more complicated, of what I could do. So this is actually part of the another function that's provided by Salt by default. So I could have a symlink function because I want to create a symbolic link on a remote machine, and then it's as easy to implement as just try to use the OS symlink function to create a symbolic link and then return whether it succeeded or failed, and then I can run this by using a globbing pattern and decide which machines need this symlink. And my results, the results of a Salt function don't need to be necessarily true or false. I could return, for example, a list. So in this example, which is also taken from a module provided by Salt, I can run a Postgres query, right? So basically in the implementation, I just return a list of rows, which is the result of running this query. So I could potentially, maybe run a query on a Postgres server that's listening only in a local port or in a Unix socket, but it's in a remote server. So I just order Salt to run this query and get the results in a nice format without having needed to log into this server, and I could potentially run this query on many different servers all at the same time. So this is just a small sample of the modules that come available with Salt by default. For example, there's like a brew module to manage packages on a Mac OS machine. So yeah, you could, if you have tens or hundreds of Mac OS machines, install a package in all of them at the same time. You could do IP tables rules for setting up firewall rules in all of the machines on your organization. Let's say suddenly you want to allow access to a service you just installed in maybe 3 machines. So you tell Salt to open those ports using IP tables. Virtual env is available too. You can create in a remote machine a virtual environment and then tell it to install a set of requirements that you have. So this is just this is like a small list. The actual list of modules that's included with Salt is a lot larger. And the nice thing is you can also add your own, right? So basically, just by writing a function that returns everything in the format that Salt expects and integrates with Salt, you could write your own, the functionality you need to be doing actions on your infrastructure. Basically the model that Salt uses, so how do I send these commands to all of these servers that are in my infrastructure? Basically, Salt defines a master server and a set of minions, right? So you have one master, and every other machine is a minion. And then Salt opens 2 ports. One is, it uses 0MQ, and so one port has a pub sub socket, so all of the minions subscribe to it and listen for commands that the server requests to be performed, and then they do their work, and then later when this work is finished, they reply to a separate master port with the results, right? So just the master gathers all of the results of all the machines and can display it to you. And the master can sync modules. So basically, if I just wrote a new function that I need to perform a certain operation, I can just put it on the master, and there's a function to sync all of these modules to all the minions, and then all the minions can automatically have this new functionality available to be used. So basically, there's, as you can imagine, a lot of uses for this. Since each module is basically a Python function, you could be doing whatever whatever Python can do in sets of machines, right? So you could be handling many servers and yeah, implement a lot of different functionality. But a very common requirement for developers or administrators is configuration management. So Salt has a powerful built-in module that's just dedicated to configuration management. Configuration management basically means that you can specify a machine's configuration in a declarative way, and then apply a function to ensure that a machine's configuration matches the description of the configuration that you decided. What does a configuration mean? It means, for example, a set of installed packages, specific versions, or maybe you just want to say you want the latest version of a package to be installed. It also means maybe you want a configuration file to be present or absent. You may want certain services to be up and running. You may want certain firewall rules to be applied. You may want, for example, a Postgres or MySQL or Oracle database to be present, and not only to be present, but to have certain characteristics. So whatever is needed for a machine to be ready to do the work that it is purported to do, right? Which it might mean a web app server, or a web app DB server, or it might mean whatever you need. Maybe you're running a scientific computing application, and you need 1,000 nodes that are all configured in a certain way to interact and to perform the actual scientific work. So basically, the Salt state module allows you to define a configuration, and then you can have this configuration in a centralized place, and you can tell Salt to apply this configuration to your machines. So this is a sample top file. So this is the beginnings of a Salt state tree. So in the top part, you can see I define, using some globbing patterns, the configuration requirements for each of my types of servers, right? So here I'm saying I want all my servers to have configured the users. I'm going to dive into the details of what does users means in this case, and I want SSH to be configured in all of these machines. And then maybe my app servers, I want Nginx and UWSGI to be running, and I want my own app to be also configured. And in my DB servers, I want Postgres to be installed and up and running. So this is a YAML file, which is a markup language. So we can build a directory structure with files like the one I previously presented. So we have a set of YAML files, and then we have the top file, which I just showed, and then I have, like, for example, a users init.sls file. So basically, on the previous file, when I was saying, I want all the machines to have the users configuration, what I'm saying is apply the configuration in my users/init.sls file, right? And there's also like an SSH init.sls file, which I was also including here. And you can also see that I'm including more files that are not salt configuration files, but are files that I need to configure those machines. So for example, I put my public SSH key in the salt state tree, and I put the configuration for my SSHD server, and I can place everything in this centralized directory structure, and that means that Salt can distribute these files and make them available to all the minions when it is applying configuration. So now to look at the contents of, for example, the SSH init file. So yeah, this is how this SSH configuration file looks inside. So all of this is a single file that's specifying two things, right? I want the latest version of the SSHD package to be installed, and I want this file, etc. SSHD config to be present in the target machine and to be owned by root and the group root with a certain file mode, and I want the contents of the file to be the same as the configuration file that I'm holding in my state tree. Okay, so so basically, okay, so then the point here is that I define this file, right, and then when I run a salt state command, all the machines that match this globbing pattern, right, or for example, which in the case of SSH is all the machines in my infrastructure, will be ensured by Salt to be running the latest package, the SSHD package, and to have this configuration file configured in this way. So this means that I can build my whole directory of state files defining how certain things must be running in certain machines, and then in my top file I define how to which machine will be applied which configuration. I showed a couple of YAML files so far which specify my configuration. You can also, by default, use Jinja to programmatically build a configuration file, right? So this is an example from like the Salt tutorial. If you want to have a set of users, present in all of your machines, then instead of writing maybe like a very big YAML file, you can write a Jinja template that generates a YAML file, and then this is taken as the configuration file for as the contents of this configuration file. Any templating system is supported. An interesting thing about Salt is that Salt cares only about a final data structure that defines how the configuration must look. But you could use any templating engine or even any markup language, like you could use XML instead of YAML to define your configuration. And the important thing is that the final output compiles to a data structure that Salt understands. But Jinja and YAML are supported by default, so if you don't have any specific requirements, you can just use that. We don't actually, in our own setup, we don't actually do this too often. We found not a very large need to be doing a lot of programmatic configuration, but your specific application may be helpful to have this capability. And then you can use an interface that Salt provides called grains to also build your configuration files. For example, in this YAML file, I'm defining, like, I want Apache to be installed in my servers, right? And then the problem is, depending on the OS, the package for Apache is named differently, right? So Salt provides an interface called grains, and you can see I'm using an if statement there to check the contents of grains OS. And then when this file is being applied to each minion, the contents of grains OS will be available with the correct value. So the YAML file will end up being the correct YAML file for the configuration for this OS. How does this information magically appear? Basically, Salt has a large number of built-in grains that you can already access. So if you were to write this in your configuration file, it will already work out of the box. But this system is also extensible. So you could write your custom grains to determine and to provide static information at the time that a Salt state is being applied at a machine, and then do logic to determine what needs to be installed or what needs to be configured. And you can also use grains for logic in your targeting, right? So you could also say, I want to apply this state or run this function in all my machines that are using a 64-bit architecture, or all my machines that are running Ubuntu, or all my machines that are running Windows. So this is, or if you wrote a custom grains module, then yeah, you can also use that for targeting specific machines. So, for example, I could have a function that to define a Salt grain, which tells me whether this machine is a production machine for my app, or it's a staging environment, or it's a test environment. So, with the power of Python, I can just write any function and end up putting this value into the grains subsystem. And so this value will be available in that YAML file that we were looking at before when my states are being applied. And the values can come from static data too, or from any Python function. So it's pretty flexible. So one of our major problems in we do a web application, and we have the problem of deployment. So You know, if you're dealing with that, you know that involves, you know, a lot of things, like you need to be keeping maybe multiple versions of your application in sync. Maybe you need to update, you know, maybe you're using a Git or a version control repository to pull your versions of your application, or maybe you have to reload or stop or start services each time you're publishing a new version. So you could write a custom function to perform a deployment, right? And then you could potentially deploy your app from a single point just by running a single command that knows what to do, because your Python function knows everything it needs to do to push a new application version. So for small installations, or in cases where you don't want to be running a machine that's acting as a salt master, and it's a lot of hassle to set everything up, and like a client network, client server infrastructure, just to be able to apply, to use configuration management to maintain your machines. Salt also provides a masterless mode where you're running a standalone minion. So basically you install only the package for the minion in your machine, and then copy the whole state tree that I was showing before to this minion, and then tell it to configure itself according to this set of rules. And if you're just starting out, this is a pretty helpful option. Okay, so now I'll talk a bit about our process migrating to SaltStack. Basically, we weren't using any configuration management or remote execution tool. Well, we were using Fabric before starting to use SaltStack, but we weren't having any configuration management tool. So our main concern when we decided to use Salt was we need to keep all our environments in sync. You know, as I explained before, I want all of the machines to be configured in a certain way, and we also want our configuration to be in version control, right? Because configuration also has a life, and it changes, and you need to know, you know, at which point in time how was your server configured. Maybe you need to go back and forth, and all of the benefits that version control provides. So there's many existing tools for configuration management available. Some of the most famous ones are Popper and Chef. Another one that's interesting is Ansible. Ansible, we didn't know about it when we started migrating to SaltStack for our configuration, but it's also an interesting tool. It's also written in Python. As I understand, it doesn't have remote execution capabilities. So it is useful if you have a very small installation that you want to configure your remote server from your laptop without having a central master server with all your configuration. And there's a talk about it tomorrow, actually. It's in Japanese, but if you're interested in configuration management in general, it's probably worth taking a look at that presentation too. So why did we decide to use Salt? Yeah, the PDF is a bit messed up, but basically one of the big reasons for us to use Salt is it's written in Python. It means if you're a Python shop like us, you don't need to manage a new language just to start using like a configuration management tool, or if you want to add modules and you already know the language, and it's very easy with your existing tools to just develop more more modules that you need. It's fast and scalable. you can use it in your home network, and like you could potentially use it to just configure your laptops and desktops and maybe 1 or 2 servers that you have. But it is also there are also cases of it being used for about 10,000 servers. So actually, one of the original design decisions of Salt, as I understand, was to build remote execution, to do remote execution really fast. So this is one of their core philosophies. So in the case, yeah, that you have many servers, Salt Stack is really useful. It's very easy to get started with. There are even instances with people managing like 3 Salt servers with a Salt master running in a Raspberry Pi. So you just can, yeah, it's very easy to just install the packages and begin playing around and set everything up. It's very flexible. It's, you can use Salt to configure your cloud infrastructure, or maybe you have a data center with dedicated servers, and also different operating systems, right? Like as you saw before, you could like configure your Mac OS packages, your Solaris packages, your Linux packages, or do like Windows-specific operations on your Windows machines only. So that is pretty helpful. Yeah, well, the feature set, as I said before, so it was originally built as a remote execution platform that's really fast, but with the module system, the configuration management part was developed too. So this is a pretty big feature, but you can write more Python modules to extend it. So it's basically just growing in features. Also the community. Salt has a very big community, which, yeah, it's growing pretty fast. Actually, last year in GitHub, named Salt Stack as one of the projects with the most number, the biggest number of top 10 biggest number of contributors in 2012. So basically this means that Salt is a very healthy project that's growing, and it's not going to go away pretty soon. So if you need, the promise of stability and you're worried that the tool that you're using to manage your infrastructure is going to go away, Salt provides peace of mind so that you can use it. And finally, Salt has a commercial support. There is a commercial offering called Salt Stack Enterprise. So if your use case requires actual commercial support, that's also available. But basically, out of all of this list, for us, the main drivers to adopt Salt were it's written in Python, and the community also gave us a lot of peace of mind that this is a good tool to use for our infrastructure management. And there's a lot of people happy with it, so we just tried it, and yeah, it worked out pretty well. So how did we go after deciding to try Salt, to go from an ad hoc setup to using Salt? First of all, we started using Vagrant. Vagrant is a tool for managing virtual environments in a very easy way. And there's a Salt plugin that allows you to provision the virtual machines that you bring up using Salt. And very recently, I think last week or the week before, this provisioner was merged into the Vagrant project. So basically, if you download the latest version of Vagrant, then the Salt provisioner is already included. And this allows you to test your Salt configuration locally and easily. you can play around and bring up machines and destroy them pretty fast without needing to be actually running a dedicated hardware for it. And basically, this lets you just configure everything in a way that will work when you put it in a real server without costs of running hardware. Then when we were satisfied that we have a solid state tree that replicates our infrastructure needs in the correct way, we used Salt Cloud, which is an associated project of Salt, to bring up and provision servers in the cloud. Basically, you can bootstrap, for example, a Salt master in a single command like this. What this is doing is saying, bring up a machine configured as a Salt master. Salt master is a configuration file that I may have, which may say, for example, bring machines up in like this AWS region or in this Rackspace Cloud region using this API key and make it a Salt master. And then I define the name of the machine, and then that will bring up the machine and install the master package and make sure everything is running. And then with another command, I can bring up a minion, which, for example, I may have a DB server configuration, and this will bring up the machine, install the minion package, tell it which is the host name of the master. So basically, after running this, I can log into my Salt master server and watch the minion already and do commands. So this is pretty helpful for bringing up a lot of machines quickly in a repeatable fashion. There's also the problem of distributing secrets. So you may have like API keys, database passwords, or any other piece of secret data. For that, you can use Pillar to distribute your secrets. Pillar is similar to Grains, which I described before, but it has the feature that it is only distributed to the minions that are matched by the matching targeting system. So if for example my SSL certificate is only needed on the web servers but not on the DB servers, there's no need to be sending those files over there. So this is pretty helpful. Yeah, this is an example. If I have a Django app, I could use a templated configuration file and use Pillar to bring up my secret data, like my database name and password, and then that will only be available on the machines that I need it to be. And then there were security considerations when we were setting up Salt. So what you need to take into account is minions don't open any port. So basically, there isn't any special firewall configuration that you need to be running on the minions, and the minions will just connect to the master that opens 2 ports, as I said before. The master listens in these 2 ports for incoming connections, and then the master needs to approve a public key sent by the minion. So basically, the minion is using a public-private key pair, and with the master, you can just decide which minions are the legitimate ones to prevent any attack attempts. But still, it is recommended to use firewalls or something like Amazon security groups to protect your master password and only allow connections from your minions, just to be on the safe side and prevent any security breach because of a vulnerability in the Salt master. Yeah, thank you.
Okay, great. That was interesting. Do we have any questions from the floor?
So you had the top state it was from earlier, and then you had, you know, like 5 or 6, like do Postgres, do, I don't know, Nginx, whatever.
Yeah.
Right. What's the ordering in those, and can you make them dependent? So like if Nginx fails, it won't go to Postgres and it'll fail out and give you some issue, or?
Yeah, that's a good question. Yeah, basically, by default, the ordering of salt, you know, of requirements in this configuration file is undefined. So by default, you don't have any guarantee of the ordering, but in your configuration files, you can use you can specify dependencies. So for example, I didn't put it here for reasons of shortness, but I could say I have 2 states here. I'm saying I want the SSHD package to be installed, and I want this configuration file to be present. But installing, you know, if I were to like place this configuration file here and then install the SSH package, maybe SSH will overwrite this file, right? So I can add a line here saying this state requires the SSHD package to be installed, and then the salt system will honor this ordering, and you can basically build any dependency graph as long as it's not circular. Obviously, you can build any dependencies that are required.
Okay. Do we have any other questions? No questions about minions, zombies, or ghosts? Yeah.
I have a question. I apologize, but I don't really understand the different use cases for Fabric and Salt. And are they solving the same problem? And is there any defensible reason to use both of them at the same time?
No, I mean, we're not, I mentioned Fabric, we were using it before, but you could replace Fabric with Salt, because they basically are providing the remote execution.
They're solving the same problem?
Right, yeah.
And you preferred Salt for which reason, specifically?
Well, Salt, for example, has the state management module. So that provides a way to specify configuration declaratively. And you could also potentially do this with Fabric, but Fabric we found has like a more imperative way of working. And
so it's just a preference for the declarative.
For the declarative way of.
Okay, thanks.
Yeah.
Okay, so we have one more minute for maybe one more question, if anyone has any. Okay, I think we can close. Thank you very much.